to Solving Lesson 10, Part 3. Solving multiplication inequalities. The multiplication property of inequalities. Case 1, you may multiply by the same positive number on both sides of a true inequality, and the inequality remains true. Case 2, you may multiply by the same negative number on both sides of a true inequality, and the inequality remains true if the inequality direction is reversed. That's the important thing here. Notice that it's less than or equal to, or just less than. Negative 3 is less than 11. It's also true if I multiply by negative 3 and switch the direction of the sign to be greater than. So that's the important thing. Now the same thing's true for the division property of inequalities. So solve each inequality, graph the solutions, and verify a solution. So let's start with solving. We would divide by 2. Because we're dividing by a positive number, we don't need to do anything to the sign. We get b is less than negative 6. We need to have negative 6 on our number line. And I'm going to fill in some additional numbers here. Negative 6 is an open boundary, and b is less, so my arrow needs to go towards the less numbers, the less than numbers. Example 269. 2/3 h is greater than or equal to 5/6. I need to multiply both sides by the reciprocal of 2/3, which is 3/2. Because I'm multiplying by a positive number, I don't have to worry about switching the sign. 5 times 3 is 15 over 6 times 2, 12, and 15/12 does reduce to 5/4, or 1.25, but I'm going to leave it as a fraction, 5/4. So on my number line, let's go ahead and count by halves. So 1/2, 1, 1.5, 2, 2.5, and 5/4, that's 1 1/4, filled in boundary, so a closed boundary. And the h is greater than, so my arrow needs to go to the greater than numbers. And there is my solution. Oh, I forgot to verify a solution. Let's go back and do that here. When I verify a solution, I need to pick a solution. Let's pick negative 10. 2 times negative 10 is going to be less than negative 12. That's negative 20 less than negative 12, which is true. That's a negative 12. Okay, example 269. Let's pick a solution. How about something that's easy to multiply by a multiple of 3? Let's actually pick 3. So 2/3 of 3 is greater than 5/6. 2/3 times 3 would be 2. Is 2 greater than 5/6? It sure is. That solution checks out. Example 270 on the top of page 38. Negative 5.4u is greater than 18.9. We need to divide by negative 5.4. Okay, little alarm should be kind of going off in your head. Anytime you divide by a negative, you need to automatically switch the sign. So 18.9 divided by negative 5.4 is negative 3.5. So u is less than negative 3.5. Now let's see, let's do it this way. We'll count by halves, but only label every other one. Negative 3.5 is between negative 3 and negative 4. It's an open boundary. U is less, so my arrow needs to go towards the less than numbers. And then I'm going to pick a solution and check it. Something, let's do negative 10. Negative 10 is an easy number to multiply. Negative 5.4 times negative 10 is greater than 18.9. The original problem with negative 10 plugged in. Negative 5.4 times negative 10 is positive 54. 54 is bigger than 18.9 is true. So that checks out. Next example. Negative 286 is greater than negative 22m. I'm going to divide both sides by negative 22 and immediately switch the sign. So negative 286 divided by negative 22 is 13. 13 is less than m. or m is greater than 13 if we just switch it around. So 13 needs to be on my number line. And it is an open boundary. And m is greater, so my arrow needs to go towards the greater numbers. Then I need to pick a solution and try it out. Let's try 15. So negative 286 is greater than negative 22 times times a positive 15. So negative 22 times 15 is negative 330. So negative 286 is greater than negative 330. That is true. So the answer checks out there. Okay, example 272. 2 1/3 f is less than or equal to 19 5/6. Well, we need to change these to common fractions. 2 times 3 is 6 plus 1 is 7. This is 7/3 f, less than or equal to 19 times 6 plus 5 would be 119/6. We need to multiply both sides by the reciprocal, 3/7. And I believe there's going to be some reducing here. Yeah, there is. I'm going to reduce first. 7 goes into 7 once, and 7 goes into 119 17 times. 6 and 3 can reduce. I get 17 halves. So f is less than or equal to 17 halves, which of course 17 halves is 8 1/2. So 8 1/2, that's between 8 and 9. So let's just do it like that. It is a closed boundary, and f is less, so the arrow is going to go towards the lesser numbers. And then we can go ahead and check our solution. Because we are going in this direction, 0 is one of my numbers, and I like the number 0. It is so easy to multiply by. So 2/3 times 0 is 0. 0 is less than 19 5/6 is true. Okay, example 273. Here we need to divide both sides by negative 1.5. And anytime you divide by a negative, you should immediately switch the sign direction. 7.5 divided by negative 1.5 should be negative 5. So p is greater than or equal to negative 5. Okay, got my number line put together. Negative 5 is the boundary point. It is closed, so it's included. P is greater, so it's going to go towards this direction, to the right. And then we need to pick a solution and check it. I like the number 0. It's a great number. So let's try 0. Negative 1.5 times 0, less than or equal to 7.5. And this is going to be 0 less than 7.5, which is true. That checks out just fine. Sammy stacks rolls of toilet paper in a cupboard. Each roll of toilet paper is 4 3/4 inches tall. The cupboard has a shelf clearance of 15.5 inches. Well, first thing I noticed, since things are written in decimal there, I'm going to go ahead and change this to decimal, 4.75. Write and solve an inequality to determine how many layers of toilet paper rolls can be stacked in the cupboard. Okay, in order for it to can be stacked, it's got to be small enough. So the space in the cupboard is 15.5 inches. We need to be less than that. Now it's 4.75 times the number of toilet paper rolls. Let's make t equal the number of toilet paper rolls. Not tolls, rolls. Okay, we can go ahead and solve this dividing by 4.75 on both sides. Because we're dividing by a positive number, we don't have to worry about the sign issue. 15.5 divided by 4.75 is 3.263157895. And I'm sure that keeps going on for a bit. So t is less than or equal to about 3.3. We don't need all those extra decimal places. So how many rows can be stacked? Well, you're not going to cut a roll into a 0.26. You're going to be able to stack 3 rolls. Riker mows lawns for $4.50 per lawn for extra cash. He needs to save up enough money to pay for a lost library book fine of $24. Write and solve an inequality. To determine the number of lawns Riker must mow in order to have enough money to pay for the library fine. Well, to have enough money, the library fine is $24. He's got to have at least $24. If he has more than that, that's great. But he's got to have at least 24. It's $4.50 per lawn times the number of lawns. Let's use L to be the number of lawns mowed. Yeah, let's do a little bit better with that. Lawns mowed. So 4.5 times the number of lawns mowed needs to be greater than 24. So we need to divide by 4.50. And L is going to be greater than, well, let's go to the trusty calculator. 24 divided by 4.5. I get 5.3 repeating. So he must mow at least 5.3 repeating lawns. Since he's probably got to mow a whole number of lawns, I'm going to say he must mow 6 lawns or more. Okay. All right, on the assignment, on number 1, you're solving and graphing. Let's go ahead and look at F. Divide both sides by 2.2. And that gives you M is less than 5. You can go ahead and graph that. 5 is the important number here. And it is not included. M is less, so that will go to the less than side. Then you need to check a solution. 0 is one of the solutions, so let's try it. 2.2 times 0 is less than 11. 0 less than 11 is true. There's F done. Number 2, write and solve an inequality that represents X. This time you're dealing with area. Area length times width. I'll go ahead and set this one up. Length times width is going to be 10x, but it's got to be greater than 120 square centimeters based on what this says here. You do need to solve that, but that is the setup. Number 3, you're going to solve and check your solution. 4, use the order of operations to evaluate. Number 5, simplify the expression. Number 6 is a review of factoring. 7 is a situation problem dealing with putting boxes in a storage container. And number 8, you're going to solve both the inequalities and describe what numbers will make both inequalities true. And you can include a graph with your description.